All right, boys and girls, a quick little review of the four forces of flight. Those would be, again, the thrust, drag, lift, and weight. And when we're making our paper airplane and testing it, remember that when you fly it, you're going to make a prediction of what you think will happen. And when you make your prediction, we're going to be recording it onto our flight test data log. So you're going to make a prediction. What do you think will happen? Because of your paper airplane design, I think, and remember, you're flying it only 3 times, but you filled out your prediction of what you think will happen first. So I think because of my design, it will fly, it will simply fly. We'll say that. So then we're ready to do our test. Now is when we take our airplane and we throw it, fly it, and test it. And when we test it, we're going to write down what happened. Record how far did it fly, other interesting things that maybe you noticed with it. So when you fly your plane, say for example, it takes a drastic nosedive. So you might say then it flew 5 feet. Or however far it went. And when you're watching it fly, pay attention to how strong your thrust is, how strong you throw with your arm. That would be the thrust, that's your muscle power. Pay attention to the design of your plane, because a paper airplane that has a lot of exposure of paper to the air, that would be the resistance that's causing it, and that would make drag, which makes your plane fly with more force against it. Think again of your hand out the car window. That would be the drag as the air is pushing against it, and your thrust is your arm power to push it forward. So in a paper airplane design, this surface area is causing the drag. So it's pushing, this is going against the air that your thrust is pushing it forward to, if that makes sense. So the drag is by the air, this cutting through the air is still there and it's cutting through it. Now the lift and the weight is as you're flying through the air, if you have a strong thrust to overcome this drag, and the wing design is what is going to make the air over the top go slower. The bottom, because it's a straight surface, is going to go faster. So that's your wing design. So what happens is in your paper airplane, you have your paper airplane here, okay, and it's going forward. So not quite a 3D design of it, but there's your paper airplane. The air over the top is going over the top, and the bottom, oops, we'll make your paper airplane this way, so we have a straight point, a fold here to represent the wing. The bottom air is coming straight, so this is going faster than the air on the top. This air is then going slower. So this creates, in a sense, a low pressure. So this is a low pressure. So when the air pressure is lower, the high pressure, because this is going faster, creates a higher pocket of air, and really that shouldn't be drawn that way, but it's the air is really being forced up. High always goes to low to try and balance it out. So this is causing a force to make it want to go up, which is the lift on the plane. The weight is simply the weight of it, because if I take this marker and this piece of paper and drop them, the paper, of course, is going to come down slower than the marker because it is heavier, and that's the force or the play of the weight on the whole thing. So as I fly my plane then, I see that it only went a short distance, because I maybe look at my design and go, well, I have a lot of resistance here, which is causing drag. Also, maybe I made this with 2 sheets of paper, so it's going to be heavier, so the weight is going to be heavier. So maybe my other thing that I noticed was large wing area. So I'm looking at this and thinking about these four forces and what happened to draw a conclusion. So my conclusion would be that possibly I have too much drag being created by too much area or surface area of the wing, which is making it go slower. So my conclusion is that if I maybe change my design, because here's when you have an opportunity to do that, maybe I decide to make a new fold in my wing to reduce the amount of straight up surface against the air as I thrust it through, and make less and more aerodynamic design of my plane to go through the air. So I decide that I'm going to change or fold the wing differently. Change or fold the wing once. Okay, so there is my recorded results. I think that too much surface area is causing too much drag. Need more thrust. So there's my conclusions. Okay, so then I recorded that, made my changes on here. Now I'm ready for round 2, testing flight number 2. Before I do it though, I need to make sure I write down a prediction. What do I think will happen as a result of my changes to my design based on the 4 principles of flight? So I've made my changes. Now let's see. I predict this time my plane will fly 10 feet. And I think that this time my design is more aerodynamic, so I'll have more lift. I think my plane will easier go higher because of the design. So I have slower air going here, faster air going here, as opposed to when I had it here, I had a lot of slow air because of the sharpness of the angle was maybe too much, and my thrust was not enough, so it caused not to go far and not to go high. By folding this, I'm thinking, my guess is that, my prediction is that this will cause the air still to go slower because of the design, the bottom still to go faster, forcing the air up, creating that uplift, and this still to have a nice pocket of low air, so it creates that. My weight is still the same. I'm going to increase my thrust to see what happens. Then I go ahead and make my test flight and record what happens, draw my conclusions from it, and then if I'm happy with my design and I don't want to make any changes, I would still do the 3rd flight to make sure that it is the same the next time around. Or I make changes here and do a 3rd flight. But you only get 3 times to fly it and do your testing. Today's goal is to get your test log completed, so make your test flights. If you have not completed your design, of course that needs to be finished first, your building process, before you go on to testing. Thank you.